Alright, hello, this is Miss Elliott, here to get you started with week 4's learning. Last week, we were learning all about right triangles. We first reviewed the Pythagorean theorem, and then we learned how to use the trigonometric ratios and learned how to use SOHCAHTOA, how to set up problems using SOHCAHTOA. After that, we also talked about 30, 60, 90 right triangles and 45, 45, 90 special right triangles. All of these were methods on how to find missing sides in a right triangle. Now, this week, we're moving on from right triangles to various polygons with more sides. So, a right triangle is a polygon. That is, it's a figure where all the sides have straight sides, straight segments, and none of the sides overlap. So, we are going to be learning how to find the area of polygons later on in the week. And for the first couple of days of the week, we are simply going to talk about quadrilaterals. So, quadrilaterals are four-sided shapes. So, the most famous quadrilateral that you know is probably a square, but there are many more quadrilaterals. And so, we are going to talk today about the parallelogram and all of its properties. So, getting started, we got to know, what is a parallelogram? Well, a parallelogram is a quadrilateral, a four-sided polygon where the opposite sides are parallel. Now that makes perfect sense. The word parallel is in the name. And so let's recall that we mark segments parallel with arrows. So that shows that those opposite sides are parallel. Not only are the opposite sides parallel, but the opposite sides are also congruent. That means that this side would be the same length as the side across from it, and these two sides would have the same length or measure. They're congruent. So the opposite angles in a parallelogram are also congruent. So that means that this angle is congruent to that angle. This angle is congruent to that angle. Now, the consecutive angles, that would be like this angle and that angle, well, we know they're not congruent because they're marked differently. We know they're not congruent because this one is acute, the other one is obtuse. Those consecutive angles are supplementary. That means they add up to 180. So, those add up to 180. And our next property is that the diagonals bisect each other. So we learned the word bisect in Unit 1. Bisect means split in half. So if this is a diagonal and that is a diagonal, those diagonals split each other in half. And so we can mark that with tick marks like this. This half would be congruent to that half, and this half would be congruent to the other half. Now, one thing that I want you to notice is that whenever you have parallel lines cut by a transversal, so here is our parallel lines cut by a transversal, that we will make a pair of alternate interior angles that are congruent. And there are several pairs of alternate interior angles. All the ones across from each other on the diagonals are going to match up and have the same measure. So we're going to make a quick note, just reminding ourselves that alternate interior angles are congruent. And another note before we practice using these 5 properties is that we mark sides or segments congruent with tick marks, and we mark angles congruent with arcs. So we're recalling that before we do a couple practice problems. So our first problem says ABCD is a parallelogram. Great. Find each missing measure. So if it's a parallelogram, we know that those opposite sides are parallel. We can mark that. We know that the opposite sides are also congruent. We just took a note of that. So let's mark it. If the opposite sides are congruent, if BC is 14 meters, then we know that AD would also be 14 meters. And if CD is 9 meters, then we know that AB would also be 9 meters. Also, going through all of our properties, we know that the opposite angles are congruent. We're going to mark it. The consecutive angles are supplementary. There's no way to mark that. And that the diagonals bisect each other. So if the diagonals bisect each other, then this half, AE, would be congruent to the other half, EC. So EC has to be 11 meters. And this half, BE, would be congruent to the other half, ED. So how long is BE? Well, BE would have to be 7 meters. So using all this information, we can answer most of these questions. AB, yep, 9 meters. AC, we have to add the 2 halves of 11 plus 11 and get 22 meters. And BE is 7 meters. Now let's talk about the angles. I just reminded us that alternate interior angles exist. So if I jump over this diagonal, that means that that would be 49 degrees. And 27 would go in that spot as well. And 43 would go here as well. So this question asks us, well, what is the measure of angle BAD? So this entire angle. To find that, we must add 49 plus 27. And when you do, you will get 76 degrees. Now, I have a couple bonus problems for you. I want you to find the measure of angle ADC and angle ABD. In order to do that, you will need to remember that the consecutive angles are supplementary. Now, we're going to use this property in the next problem, that the consecutive angles are supplementary. In this problem, it says if it's a parallelogram, find the measure of angle PSR. So, we know that the opposite angles are congruent. So when two things are congruent, we set up our problem part equals part. And the consecutive angles are supplementary. So when two things are supplementary, we don't set it up part equals part. We set it up part plus part equals whole. And what is that whole? It is 180. So let's set up and solve this equation. 7x minus 13 plus 4x minus 5, that's our two consecutive angles, they add up to equal 180. We have to combine like terms. The 7x and the 4x make 11x, and the negative 13 and the negative 5 makes negative 18. We add 18 to both sides. 11x equals 198. Divide by 11 on both sides, and we find that x equals 18. Now that would be all fine and dandy if the problem asked us to find x, but it doesn't. The problem asks us to find angle PSR. And so you might think, oh, there's nothing to plug in. So where are we going to plug in our x? We're going to plug it in on this opposite angle. And so once we find the measure of angle PQR, since these angles are congruent, we'll be finding the measure of angle PSR. So 7 times 18 minus 13. 7 times 18 is 126. Minus 13, we get 113 degrees. Now, before we end this video, I really quickly want to talk to you about some very special parallelograms. So these properties, these 5 properties, work for every single parallelogram in existence. So these 5 work. And some parallelograms have special properties of their own. So all of these shapes up here, a rhombus, rectangle, and a square, they're all parallelograms. Now the definition of a rhombus is that it is a parallelogram with 4 congruent sides. And it has a couple special properties in addition to the 5, in that the diagonals are perpendicular and the diagonals are angle bisectors. Now, a rectangle is a special parallelogram that has 4 right angles. It has 4 congruent angles. And its diagonals are congruent to each other. And a square has 4 congruent sides and 4 right angles. It has all the special properties of a rhombus and a rectangle, meaning that its diagonals are perpendicular, congruent, and the diagonals are angle bisectors. All right. Thanks for watching. Have a great rest of your day.